All right, so here we go. So this is 2017 FRQ number 1. All right, so you're given this Atwood machine. You've got these two blocks. Question A asks you to make a free body diagram for both blocks, right? Of significant importance is the problem tells you which block is heavier. So this guy is M1, this one's M2. So the masses can vary, it says, but it says that M2 is always bigger than M1, which is important because that tells us that our system is going to accelerate this way, right? Okay? So question A says, on the dots below, which represent the blocks, draw and label the forces, not the components, that act on the blocks. Each force must represent a distinct, each force must be represented by a distinct arrow starting on and pointing away from the appropriate dot. The relative lengths of the arrows should show the relative magnitude of the forces. All right? So when you draw M1, what forces have we got, you guys?
Tension.
Tension and gravity, right? So your gravity should be labeled as M1G, right? And tension. Now, how long you draw this arrow is totally arbitrary, but that one thing determines the length of every other arrow on your sheet, right? So, because M1 is going up, what does that tell me about my tension force? It's got to be bigger, so I need that tension arrow to be longer. Follow?
Yeah.
All right? Then, when you draw M2, automatically, what do I know? That tension force has to be the same, and therefore your length should be the same. Notice they gave you little boxes so you could count, right? All right? And then finally, what other force is on M2? Gravity. Is it bigger or smaller than the tension? Bigger. It has to be because it's accelerating downward, right? Cool?
Yes.
It is totally acceptable. No, let me say that differently. You should leave G in. Do not plug in the, don't write 9.8 on. Don't write 10 on. Write it as MG or M1G. Okay? Peter?
So when I do this, I put it as FG. Is that not okay?
I think that's acceptable.
Okay.
Yeah. As long as you have the appropriate length.
Right, right.
Although, make sure that if you did F1G, F2G to indicate that they're different forces.
Okay.
Good? Molly, did you have a question or somebody over here? No?
It's over here.
Yeah.
I think as a question related to that, it says label the forces, not components, and I don't really know what that means.
It doesn't really apply to this problem. I thought it was weird that they wrote it. When that would apply is like
Like if there's numbers?
no, like if you had an inclined plane, you would draw your force of gravity instead of drawing the parallel and perpendicular components.
Oh, okay.
Like if there was a force at a weird angle.
Yeah, that's
I don't know why they
didn't
wrote
say
it on
that
this one.
here. Okay.
I think that's standard terminology. I think anytime they ask you to write a free body diagram, it'll have that terminology where it'll say label forces, not components.
Control.
And I'm guessing they just did that so they wouldn't be giving anything away. You know?
Yeah, because if they didn't include it, then it would seem that it's all.
Right. All right, everybody good with that? All right, and notice how do we need to go through the points, you guys? Is that valuable, how the points are assigned?
I mean, it's
It's
listed in
a
the
thing
packet.
they always stress at the conferences, but I mean,
If it's in the packet, we can go through it ourselves.
okay, is everybody cool with that? All right, cool. All right, now, part B. So I will tell you, the way that they teach you to do part B is not, or let me say that differently. The way that they ask you to do part B is not the same as the way I taught you guys to do it. Right? Part B wants the acceleration. Okay, so the way that I would encourage you guys to do that is the amorphous blob thing, right? Okay, but if you read the instructions, that is not how they want you to do part B. Okay? So if you did amorphous blob, like if you said, all right, here's my pulley with my two masses. Oops. Well, I just changed colors. Deal with it. All right? So if you thought, okay, well, my net force is...
Just so you know, this is an unannounced but planned fire drill. Thank you.
Yeah! All right, so as I was saying before we were interrupted by fire, so to do this problem, the instructions very explicitly say to write an expression for the acceleration of each of the objects, right? So you can't do amorphous blobs. Because when I looked at this, the first thing I thought was, oh, well, this is easy. We've got force of gravity number 1, force of gravity number 2. So your net force is the difference between those divided by your total mass, right? Okay? But that's not how it wants you to solve it, all right? So you really have to do it using a system of equations where you write an expression for the net force on mass number 1, write an expression for net force on object 2, and then solve it using systems of equations. So yes, this was totally written for McKeever. Does anybody need me to go through how that works? Why do you have to do it that way? Because that's what they asked for. Because the directions say, using the forces in your diagram above, write an equation applying Newton's second law to each block. Okay? So you're not allowed to treat it as a big system. Which is weird to me that they want you to do it that way. But does anybody want me to run through the algebra on how you get from these equations to that equation down at the bottom? Going once, twice, sold. Okay, cool. Now, the next page says the magnitude of the acceleration A was measured for different values of m1 and m2. The data is shown below. The data are shown below. So it says indicate below which quantities should be graphed to yield a straight line whose slope could be used to calculate a numerical value for the acceleration of gravity due to g, or the acceleration due to gravity g. All right. So here's the deal. On that previous page, we decided that acceleration is m2 minus m1 over m1 plus m2 times g, right? And so we need to graph something so that, how is it worded? So the slope could be used to find g. So if you think of y equals mx, our goal is we want g to be our slope, right? So what should I put on my y-axis?
M2 minus M1. Oh, wait, no. Y-axis A.
Y-axis should be acceleration, and then m2 minus m1 over m1 plus m2 should be my x-axis, right? There are other ways of doing it, but in my mind, that's the easiest, most direct route. Follow? So what you needed to do then was use the extra rows of the column in some fashion so that you could figure out what m2 minus m1 over m1 plus m2 was. I just did it in one, so I only used one of the rows. That's okay. Good? Any problems with it? All right, and then the graph is shown there on the solutions manual. Everybody cool with that? All right. So once you've got your graph plotted, talk to me about the points you pick. I would, if I think one that they only say graph. Well, talk to me about the points you pick. Can I just pick two of the data points and find the slope between the two data points? No. The whole point of drawing a best fit line is you're kind of averaging out any sources of error, right? So you need to pick points that are on the line. All right? Ideally, you can find points where it crosses at an intersection so you can read them clearly. Okay? But list out what your points are, find the slope, and then once you're done, write g equals whatever you get. All right? They're pretty forgiving. Do you know what I mean? Like when I did it, I think I got 11 meters a second squared because I didn't do a great job drawing my best fit curve. That's okay. Okay? As long as you go through the process correctly. Okay? You can use a linear regression, and I think the answer key speaks to that. And if you know how to do linear regression, awesome. Cool?
You have to say that using linear regression.
I would say that. I would say using linear regression, I got.
That's what the answer is. Yeah.
Yep.
It says you have to state it.
All right. So, does anybody want me to say anything else about that problem? Is everybody cool with this idea of taking data and creating a linear graph out of it? For whatever reason on this test, they love that. Okay? And if we had done more labs, I would have stressed that, but we didn't, so sorry. Just so you guys know, a couple people were asking about the final. I think that's what we're going to do for a final exam. Is I'll split you guys off, and each group will do a lab, and then we'll present out, and I'll go. Good job. I don't know. Let me think about that. All right, everybody's good with number 1, yes? All right, number 2. Oh shoot, we're not done with number 1. I'm sorry. So the next part says the experiment's now repeated with a modification. So your modification is this. So it says for the same values of M1 and M2, is the magnitude of the tension going to be higher, lower, or equal to it in the previous setup? So there's a real quick way to do this. Thoughts? Sure.
Well, M1, like it doesn't have, like the normal forces like canceling out the gravity. So it's just like you really only have the force of gravity of M2 producing.
And therefore,
So it's lower, right?
yeah. The way I would think of it is that there's no resistive force resisting the motion of 1, so your overall acceleration has to be bigger, right? And that means you have to have less tension resisting the motion of mass 2. Cool? Alright. And then G, the value determined for the acceleration due to gravity, G is lower than the first time you did it. Give a reason why that would be true. So why might you get, experimentally, why might you get a smaller acceleration of gravity here? Well, friction in the pulley would exist both times. Friction on the table, though, right? Do you guys agree? Isn't friction between the table and mass 1 going to slow the system down? Right? And so that would result in a smaller calculated value of G. Yes?
So in the question, it says that it's on a smooth horizontal table. So just because it says smooth does not mean it's friction.
Correct. If it wants frictionless, it will explicitly say frictionless.
Okay.
Good?
That's what it is.
Yes. Yep. Yes, exactly. All right, everybody good? All right. Let's see. This next one was the real deal, right? This one was, I think, probably, of the 3, probably the toughest. All right, so we've got a block of mass M starting at rest at the top of an inclined plane. It's going to slide down. It's going to slide across this horizontal surface. There's negligible friction between the block and both the inclined plane and the horizontal surface. So, to your point, that's what that's talking about, negligible friction. All right. 2A Roman numeral I says derive an expression for the speed of the block just before it collides with the spring. Please make sure that you explain your thinking. Okay? I believe, if I can find the answer key, it says that one of the points is awarded not just for answering it, but for saying that the total energy is the same at the top and the bottom, right? Where is my answer key? Yes.
You can say it with an equation, right?
Yes, you can say it with an equation, sure. Question 2. Yeah, so you get 1 point for correctly using conservation of energy for the block moving down the incline. So saying that the potential energy at the top is equal to the kinetic energy at the bottom, and then for solving it. Everybody cool with that? Yeah, John?
Say that in words, you just say that like MQH.
Yeah, correct.
Wait, so for 2A, you can just say like maybe
Yeah. Or GPE equals KE or whatever. Yeah. And they're cool with notation. So if you use GPE instead of UG, that's cool. Okay. Yeah.
Should we mark that down if we're using GPE, or will they just understand?
They'll just understand. They'll. All right, everybody good there? Okay. Roman numeral 2. So this one, the justification here is tough. It says, is the speed halfway down the incline greater than, less than, or equal to half the speed at the bottom of the incline? So it's saying this. You've got your ramp. So your velocity at the top is 0. Your velocity at the bottom is VF. And the question wants to know, the velocity here, what's the relationship between that and VF? Is it half of the velocity, more than that, or less than that? So there are a few different ways to get to the answer. I will say they're not equal. Yeah, so in terms of energy, it would be this. So our VF is the square root of, what was it, 2GH, right? Whereas this V, let's call this V, let's call this VM, as in V at the middle. So our VM would be, well, what's different, you guys?
H over 2.
Isn't it just the square root of GH? Right, because you're going half of the height, right? So when you divide your height by 2, the height over 2 and the 2 cancel out, so you get that, right? So this is the same as VF over the square root of 2, right? So is that bigger or less than half? Less, right? Okay, so that's one way you can explain it. All right, you can also explain it conceptually. Do you guys agree that between here and here, your average velocity will be less than your average velocity from here to here? Right? And so that means it's going to take more time. Oh, wait a minute. Hold on. What did I do?
Second half. It'll be a greater velocity at the bottom because it's gaining more speed.
This is more than half. Did I say less than half?
Yeah.
I'm sorry. I misspoke. This is more than half, right? Because the square root of 2 is less than 2, right? Why am I struggling? Oh my gosh. Not again. All right, so do you guys agree with that? That it's greater than half?
Yeah.
Everybody good now? I apologize, I misspoke. Everybody's back on board? Okay, so another way to think about this is this. Your average velocity for the first half is going to be less, right? Which means it's going to take more time to travel that first half, right? Isn't the acceleration the same the whole time? So you're going to have more time to gain speed, right? And therefore you'll get to more than half the velocity. Cool? All right. B, derive an expression for the maximum compression of the spring. Well, when we achieve maximum compression, what two things are equal? The total energy is the same as the elastic potential energy at maximum compression, right? So you can just do the gravitational potential energy is equal to the elastic potential energy, right? So you get mgh equals 1/2 kx squared, and then solve for x, right? Cool? I think isn't that hopefully the answer they give? Why do I keep getting these stuff? Okay, yeah. All right, everybody good? All right. Part C, determine an expression. Oh, this one. Somebody asked me about this one during tutorial. This one is really, really sneaky. C says determine an expression for the time from when the block collides with the spring to when the spring reaches its maximum compression. It's rare that they do this, I think, but there's totally a trick to this. And once you realize the trick, it's super easy. But I remember the first time I looked at this, I was like, I need to somehow, I've got a changing force, which means a changing acceleration, and I need to somehow find an expression for the time it takes to get to a velocity of 0, right? And the calculus behind it is ugly, all right? But there is a trick to it. You have an idea, Justin?
Yeah, you know the period of the spring's motion, and it's a quarter of the period because you're going from equilibrium to one end.
Very good. Yeah, so if you imagine that the block stuck to the spring. If the block was to stick to the spring, you'd be going from equilibrium position to stop, and then it would be in simple harmonic motion, wouldn't it? Okay, well all we want is the first quarter of that simple harmonic motion. Right? Because you're going from equilibrium position to stop, right? Follow? So to do part C, you just go, oh, well, the period for my simple harmonic motion is 2 pi times the square root of m over k, right? given n and you're given k, right? And we want, well, you're given those as variables that you're allowed to work with, I should say. Right? Okay, and like Justin said, our motion is a quarter of that. So you get a quarter of this is going to be pi over 2 times the square root of m over k. Does that make sense, you guys? Okay. That one took me a minute to figure out when I was solving this. All right. Now, part D. My guess is we'll get through D. I don't know if we'll have time to do E or not. So D, this is one of those drag force problems that we spent way too long on at the beginning of the year. All right? And yeah, so here's how you do those. So it says the block is again released from rest at the top of the incline, and when it reaches the horizontal surface, it is moving with a speed of v naught. Now, suppose the block experiences a resistive force as it slides on the horizontal surface. The magnitude of the resistive force F is given as a function of speed v by F equals beta times v squared, where beta is a positive constant with units of kilograms per meter. A asks you to write a differential equation, and then 2 asks you to solve it, basically. And it gives you the answer, which is unusual, I think. Okay? So here's the deal. So as the block is sliding, it's going to have a starting velocity of v naught. Its motion is going to be impeded by this force F, which is negative beta times v squared, right? Cool? All right, so this is basically net force equals net force. Mass times acceleration equals negative beta v squared. Follow? All right, so the trick then, it asks you to set up a differential equation that will allow us to solve for the velocity as a function of time. But the problem is, time isn't in here anywhere, right? So, what we're going to do, and this is always the process for this, you guys, anytime you have where you're given a resistive force that depends on the velocity, you're always going to replace A with dv dt. So this becomes m dv dt equals negative beta times v squared. That's Roman numeral 1. Good?
Yeah.
Questions with it? All right. Now, to solve it, what you're going to do is you multiply both sides by dt. So you get m dv equals negative beta v squared dt. And now we need to do what's called separation of variables, which in English means get all of your v's on one side and all of your t's on the other side. Okay? So, I'm going to divide both sides. You can either divide by v squared, or you can move the beta also if you want. It doesn't really matter. Which of those two things seems more intuitive? Do you want to move everything or just the v? Everything? Okay. So if you move everything over, you get this. Negative m over beta v squared. Nope, sorry. V squared dv equals dt, right? Follow?
Yeah.
All right, so now what we're going to do is we're going to integrate both sides of this. So I'm going to integrate this guy from a time of 0 to some arbitrary time t. And my velocity gets integrated from, at time 0, what's our velocity? V naught to v final, which is my velocity at time t, right? Make sense?
Yeah.
Any problems? This is a thing, so any questions before I go on? You guys are weirding me out with how quiet you are. Everybody's good? Okay, cool. All right, so this guy, what's the integral of this mess over here? Just gives you t. Okay, the integral of dt is t, and then you evaluate it between t and 0, so you get t minus 0, which is just t. All right? On the other side, I'm going to rewrite this. It's the integral from v naught to v of t. I'm going to pull out the m and the beta, and I'm going to write 1 over v squared as v to the negative 2. Because then you can just use, so everybody see what I did? I pulled the constants out, And I don't like 1 over v squared, so I just wrote it as v to the negative 2. Cool? So now you just use the power rule. So what would I have to take the derivative of to get v to the negative 2? Negative v to the negative 1, right? So now I've got, my t is still t. On the other side, I've got negative m over beta times negative v to the negative 1, evaluated between v naught and v of t. Let me calibrate my board. And then plug in your numbers. So you get t equals, you guys agree that the negatives cancel there? So you're going to get m over beta times v of t minus, or 1 over v of t minus 1 over v naught, right? And then, why am I unhappy with that? Oh, right. Oh, I see what they did. Yeah, and then just if you multiply both sides by beta over m, it gives you what they have there. Cool?
Could we leave in m over beta?
No, I think you need to break it down to the form that they've got.
Oh, right, because they give you what it should be.
Yeah.
Okay.
So you need to algebra that until you get to that. Yes.
So for part 1, they want you to
Hey guys, quiet, please.
they just want you to put dv over dt equals negative beta v squared over m.
Yes.
So they want you to
If you go a step further, that's okay. Do you know what I mean?
yeah.
Oh, yeah. All right, so we'll pick up here tomorrow. Do those multiple choice problems tonight, okay? 45 minutes. If you go over, just make a note. Yeah, it's super low. Yeah, you guys are going to kill this.
Lower than a 51%, I'm good.
Honestly, doing this, I did feel like I knew everything. Like,
Say that again?
I felt really